Hello everyone. Today we are discuss about RAK receiver. RAK receiver is used in code division multiple access based. It can combine multipath components which are time delayed version of the original signal transmission. Combining is done in order to improve the signal to noise ratio at the receiver. RAK receiver attempts to collect the time shifted version of the original signal by providing a separate correlation receiver for each of the multipath signals. The basic idea of a RAK receiver was first proposed by Price and Green in 1956. Due to reflections from obstacles, a radio channel can consist of many copies of originally transmitted signals having different amplitudes, phases, and delays. If the signal components arrive more than duration of one chip apart from each other, a RAK receiver can be used to resolve and combine them. The RAK receiver uses a multipath diversity principle. Multipath channel model. A multipath can occur in radio channel in various ways such as reflection and diffraction from buildings, scattering from trees. M-finger RAK receivers. The RAK receiver utilizes multiple correlators to separately detect M strongest multipath components. The output of each correlator are weighted to provide better estimate of the transmitted signal than it is provided by a single component. Demodulation and bit decisions are then based on the weighted outputs of the M correlators. Each correlator detects a time shifted version of the original code division multiple access transmission. Each finger of the RAK correlates to a portion of a signal which is delayed by at least one chip in time from the other fingers. It's a RAK receiver implementation diagram. Assume M correlators are used in a CDMA receiver to capture M strongest multipath components. A weighting network is used to provide a linear combination of the correlator output for bit decision. Correlator 1 is synchronized to the strongest multipath M1. Multipath component M2 arrived T1 later than M1 but has low correlation with M1. The RAK receiver uses several baseband correlators to individually process several signal multipath components. The correlator outputs are combined to achieve improved communications reliability and performance. In a RAK receiver, if the output from one correlator is corrupted by fading, the other may not be, and the corrupted signal may be discounted through the weighting process. The M decision statistics are weighted to form an overall decision statistic as shown figure. The output of the M correlators are denoted as Z1, Z2 and Zm. They are weighted by alpha 1, alpha 2 and alpha M respectively. The weighting coefficients are based on the power or the signals to noise ratio from each correlator output. If the power or signal noise ratio is small out of a particular correlator, it will be assigned a small weighting factor alpha. The weighting coefficients alpha M are normalized to the output signal power of the correlator in such a way that the coefficients sum to. Due to multiple axis interference, rack fingers with strong multipath amplitudes will not necessarily provide strong output after correlation. Choosing weighting coefficients based on the actual outputs of the correlator yield better rack performance.